viewers, welcome back to my YouTube channel. So today we are going to code this problem, that is the average of levels in a binary tree. Okay, so we have already discussed the approach that we are going to use in order to solve this problem. So those who have not seen that video, first go and see that thing. Okay, so that you can understand what I'm doing here now. So queue, we are going to create a queue. This is basically going to store the word level order traversal. Okay, level key is equal to so link linked list. Okay. Okay. Now in that queue, what we are going to do, we are going to add the root node as well as a null, which will be basically the separator. Okay. So it will mark the end of our particular level. So level queue dot add root and same thing that level queue dot add the null value. Okay. And now in order to store our average values, that is, no, the question has been asked that we need to uh, return the average value of the nodes in a form of an array. In order to store that, we need to create an array list. So since the values will come in decimal, so we are going to use the double data type. Okay, we are going to create a list double, we can name it as average is equal to new, it will be an array list. Okay, now we are going to use the while loop and check that whether the starting of our queue is not equal to null. So we can, check this thing from the whiteboard that we have created our queue basically here. And what we are going to do initially, we are going to add the root node. So root node will get added 7. After that, we are going to add the null value. So null will get added. Here is my cursor. Okay, so 7 will somewhat some will shift here and null will get placed here. So we are going to check the peak value of this list, basically the queue, of this queue, that whether it is not equal to null. So it is not equal to null since we have 7 here. So we are going to initialize the double and the nodes. Nodes will store the number of nodes at that level. So at this 0th level, we have one node. Okay, so that thing we are going to do. Okay, so while level q is the name, while level q dot peak function gives us the starting value. Uh, Peak is not equal to null. What we are going to do is we are going to initialize the double sum. Double sum is equal to 0 followed by the number of nodes. That is int nodes is equal to 0. Okay, now we will again use the same while loop. Okay, and we can take one more base here. Now what we are going to do, we are going to remove the basically the topmost value from the queue. So in order to remove, what we are going to do is we are going to use the poll function. So what is going on here, we can uh, from this step we are doing the thing. Okay, so yeah, with the help of the poll function, what we are doing, we are removing this 7 from uh, the starting of our queue. So poll function, what it does basically, it deletes and basically shows the value. Okay. So why we are deleting it? In order to store, uh, basically in order to empty the queue and to store the value in the sum. Okay, and then we will increment our node so that we can get that at level 0. Basically we have one node. Okay, so we are going to do that thing as well. And the tree node equal to level q dot poll. Okay, after that, what we are going to do, we are going to increment the sum by the value that we have got from that poll function. So sum is equal to node dot val, and we are going to increment our nodes plus plus. Okay, so we have done, suppose, this part. Okay, so we have added 3 to our sum, and we have, did the work for the level 0. Now what we need to do, we need to add their children's also. So for that we are going to write one thing, that suppose if node dot node dot left is not equal to, okay, okay, is not equal to null, then we need to add the left children. So what we are going to do is, level q dot add node dot left. Okay, and same we are going to do for right node as well. So node dot right, and again yes, we have done mistake here. Okay, so we have added the basically the child nodes also. Now what we are going to do, we are going to uh, one thing we need to check. Now what has been, the condition of our queue is, only the null is present in our queue, and we have added the child nodes. So we have added 5. So this null will shift, basically this null will go to this place, and left child will get added again. Again the null will shift, and again the null will shift, and the right child, that is 6, will get added to 6, followed by 5, followed by null. This will be the state of our queue, basically. And since, we are using the poll function, so it gives the value at the, the starting of the queue. So we need to shift this null to the very end of this queue. So what we are going to do is, level q dot add level q dot poll function. So it will take the starting value, remove it from the queue, and add it to the very last of the queue. Okay, so that we can again, get the values 5 and 6 and store it in our sum. Okay, so yeah, so after this while loop, we need to write same thing, that level q dot add level level q dot pole. Okay, this thing we need to do, and then what we are going to do is we are going to basically we are going to find the average and place it in our average list that we have created. So that we need to do here, that average dot add. So average is nothing but the sum divided by the number of nodes at that level. So sum divided by nodes, yeah. And at last, what we are going to do, we are going to return the value. Return what? Return the average. Whichever in whichever values of the average are stored. So return average. So I hope that we have not done any mistakes, and we'll quickly submit this thing. First, check the test cases. So there's an error. It is showing that at line number 16, 15, 16, 17, we need to check something. Oh, sorry. 32 reached Python. These mistakes. Okay, now I got it. Yeah, so it is getting accepted. We will quickly submit this thing. It is getting submitted. We're going to analyze the capacity. Okay, so leave it. It will be O of n only, the time complexity. So yeah, that's it. Thank you.